Hello everyone. In consolidation unit, we have studied regarding the terms used in consolidation, the test procedure for consolidation, and the parameters that are obtained from consolidation and its procedure. So now we are going to solve some numericals related to consolidation. So let us start with the first numerical. So what does it states? In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kN per meter square, changed to 0.994 when the pressure was increased to 429 kN per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Full stop. Find the settlement of foundation resting on above type of clay if the thickness of the layer is 8 meter and the increase in pressure is 10 kN per meter square. So here what are the given parameters? That is, the initial void ratio or E naught is given as 1.068. The final void ratio is given as E equals to 0.994 and the initial pressure sigma naught dash is given as 214 kN per meter square and the final pressure is given as sigma dash equals to 429 kN per meter square. So what is the formula for coefficient of compressibility? It is given by AV is equals to delta E by delta sigma, where delta is the change in void ratio and delta sigma indicates change in pressure. So here in the numerical, so what we will do, we will put all the values in this equation. So by substituting all this value, we are getting the coefficient of compressibility as 3.442 into 10 to the power minus 4 meter square per kilonewton. This is coefficient of compressibility. Next, what is the compression index? We know the formula for compression index as delta E divided by log base 10 sigma dash by sigma naught dash. Now substituting again all these values, we are obtaining the value of Cc as 0.245. Next is the coefficient of volume compressibility. So what is the coefficient of volume compressibility? MV is given by AV divided by 1 plus E naught, where we have already found out the value of AV as 3.442 into 10 to the power minus 4. So substituting this value and the value of the initial void ratio, we are getting the value of MV as 1.664 into 10 to the power minus 4 meter square per kilonewton. And last of all, what they have asked for? They have asked for the settlement of the foundation, that is a consolidation settlement of the soil when the thickness of the layer is 8 meter and the increase in pressure is 10 kN per meter square. So let us substitute the formula for settlement, that is delta H equals to Cc into H naught divided by 1 plus E naught log base 10 of sigma naught dash plus delta sigma divided by sigma naught dash, and the value of Cc we have obtained previously as 0.245. The value of H naught or the height of the thickness of the sample layer is given as 8 meters. So putting the value of 8 divided by 1 plus E naught is given already. So log base 10 of the initial pressure of the sample was 214 kN per meter square and the increase in pressure is given as 10. So 214 plus 10 by 214, logarithmic of this value, it gives 0.0188 meter. So let us convert it into millimeter by multiplying it with 10 to the power minus 3. So we are getting 18.8 millimeter as settlement of the clay layer. So this is the very basic or the first numerical related to consolidation. So let us go to the second part or the second numerical problem. So what has been given in the second numerical problem? A stratum of clay with an average liquid limit of 45% is 6 meter thick. Its surface is located at a depth of 8 meter below the ground surface. The natural water content of the clay is 40% and the specific gravity is 2.7. Between the ground surface and the clay, the subsoil consists of fine sand. The water is located at a depth of 4 meter below the ground surface. The average submerged unit weight of the sand is 10.5 kilonewton per meter cube, and unit weight of sand above the water table is 17 kilonewton per meter cube. The weight of the building that will be constructed on the sand above clay increases the overburden pressure on the clay by 40 kilonewton per meter square. Estimates the settlements of the building. So here is the diagram which is provided, where it is stated that a layer of clay and sand is given where various parameters has been provided, where liquid limit is given for the clay layer as 45%, specific gravity as 2.7, and natural water content as 40%. The layer of the unit weight of the soil has been given as, the sand above the clay layer is given as 17 kilonewton per meter cube, and at the submerged unit weight is given as 10.5 kilonewton per meter cube, and the overburden pressure on the clay has been given as 40 kilonewton per meter square. So let us solve the problem. So first of all, we need to find out the value of void ratio of the soil. So as you have studied in soil mechanics 1, we have a following relationship for void ratio, degree of saturation, water content, and specific gravity. So this equation is given as ES equals to WG. Hence the soil is saturated, so we can consider S as 1 or 100%. Hence we are getting the value E equals to W into G. So here the water content is 40%. So we will write 0.4 and specific gravity is 2.7. Hence we are getting the value as 1.08. So E value is getting, we will get as 1.08. So again we need to find out the specific unit weight or the unit weight of the submerged unit weight of the clay soil, because in sand it is provided, we have not got the value of the unit weight for clay. So as the clay layer is under the water table, so we must consider that it is in a submerged condition, and as per soil mechanics 1, we have already learned that the submerged unit weight of the soil or gamma sub is given as G minus 1 into gamma W by 1 plus E. So here the specific gravity or G is given as 2.7 minus 1 divided by 1 plus the value of E has been given, or we have find out the value as 1.08 multiplied by unit weight of water, that is 9.81. So we can find out the submerged unit weight of the clay as 8.02 kilonewton per meter cube. Hence, what is the pressure that is being created by on the soil due to its own overburden? So in the clay layer, the settlement has to be found out in the middle of the clay layer. Hence, we can easily find out by multiplying the respective unit weight of the soil with its depth. So for the first layer, the unit weight is 17 kilonewton per meter cube and the depth of the soil is 4 meter. Hence, for the first layer, the pressure will be equals to 17 into 4 plus for the second layer. For the second layer, we can obtain that the layer is of 4 meter depth, but it consists of the unit weight as 10.5 kilonewton per meter cube as it has been already been provided. So if the depth of the upper layer is 4 meter, then the lower layer is also 4 meter, as together they are forming 8 meter depth. So the value will be 10.5 into 4 meter. And for the clay layer is 6 meter thick, and we have to find out the settlement of the clay layer in the middle. Hence the 6 meter is divided into two parts, 3 meter and 3 meter. So what is the overburden of the clay layer in the middle of the 3 meter? In the middle of the 6 meter layer? So it will be 8.02, that is the unit weight of the clay multiplied by 3. So here we can get the overburden pressure as 134.06 kilonewton per meter cube at AA, at section AA. So already the increase in overburden pressure has already been provided in the numerical as delta sigma dash is equal to 40 kilonewton per meter square. and the total depth of the clay layer is 6 meter. Void ratio has been provided 1.08. So how we will get the value of Cc? So in this case, the compression index has to be substituted from the formula as 0.009 liquid limit minus 10%. So liquid limit has already been given for the clay layer as 45%. So 0.009 multiplied by 45 into 10, that gives 0.315. So substituting all this value, we are putting the value in the equation. Delta H equals to Cc into H by 1 plus E naught log T base 10 of sigma naught plus delta sigma by sigma naught. So substituting all this value, we can get the value of the settlement as 0.103 or 103 millimeter. So this is the second numerical based on consolidation settlement.